Okay, good morning. Today we're going to talk about the inverse of a function and a relation. So really the inverse, whenever you're finding the inverse of something, you're going to switch the domain and the range, which really just means you're going to switch the x and the y. So we use inverses a lot. We use them when we want to convert from Fahrenheit to Celsius and vice versa. And I'm sure that there's a lot of other things, but that's the one that comes to the top of my mind. So here you go. If you were going to go ahead, we're not going to draw a mapping. We'll just go ahead and write the inverse of this relation. So this relation is 2, 3, 4, 5, 10, 11. If you wanted to write the inverse of it, you would write 3, 2, 5, 4, 11, 10. And that's it. That's all you do for doing that. All right, so that's what's known as an inverse relation. And basically, and you don't have to get too confused with it, but the range is now the domain, and the domain is now the range. All right, so it gets a little bit harder, but really that's the whole idea behind it. So let's go ahead and look at another one. So here's the steps. If you're going to write the inverse of a relation or even a function, all you do is change the x's and the y's, and then you solve for y. So here's the first thing you're going to do. If you've got y equals x plus 3, go ahead and write these down as you go. All right, the first thing you're going to do, well, sometimes it's called f of x equals x plus 3. So I usually have to change my f of x to become a y, so I know that that really means y. Now you're going to switch your x and your y, so I'm going to do x equals y plus 3. And now the second step you do is just solve for y. So we're going to subtract 3 from both sides, and we get x minus 3 equals y. And once you go ahead and turn it around with the symmetric property, then you see what the inverse is going to be. Usually it involves some kind of inverse operation. So in this case it involved addition. The inverse will involve subtraction. All right, let's go find another one. But before we do that, let's go ahead and determine if the inverse is a function. So now you've got y equals x minus 3. If you had a table of those values, you would see that you would have no repeating x's. So if you were going to graph it, let's go ahead and graph both of these. Okay, so our functions were, our original function was y equals x plus 3. I rewrote it to say f of x equals x plus 3 so that we're used to seeing it like that also. And then the inverse we found was y equals x minus 3, but I wrote it in the right notation for pre-calculus to say f inverse of x equals x minus 3. Still means the same as y. It's just that you have the inverse. That means it's the inverse of that f function. So let's graph both of them. You can put them both on your graphing calculator, or you can graph them on your on some graph paper. So go ahead and do that. Okay, so I graphed both of them. And you'll see that, well, in this case, it's kind of boring because they are parallel to each other. They are both functions. The one thing I wanted you to see was that they are symmetric along the line y equals x. If I were drawing that correctly, you would see that they are mirror images along the line y equals x. So every function and its inverse is symmetric like that. Let's do one that's a little more exciting. All right, so now you've got the inverse of y equals x squared plus 5. So go ahead and let's follow along with the steps. What we're going to do, remember, sometimes it could be f of x equals that, okay? And then you got to switch it so that it says y equals maybe. Sometimes you don't have to do it. My math brain doesn't do that. I have to turn it into a y so that I know what I'm looking at. All right, so now you're going to go switch your x and your y. So now you've got x is equal to y squared plus 5. You only switch the x and the y. You don't switch the exponent. You don't switch a square root. You don't switch anything. You just switch the x and the y. Now we solve for y. So now we're going to end up, I'm going to switch these around. So it's going to end up with y squared is equal to, hold on, let me get that out of there. Okay, y squared is equal to x minus 5, right? Because we would have just subtracted 5 from both sides. I'm just switching them around. Now to solve for y, you've got to go and take the square root of both sides. So now you've got the square root of y squared equal to the square root of x minus 5. So let's go on over here and finish this out and simplify it. Remember, when you take the square root of a square, you end up with just that variable or just that number that's under there. So now y is equal to the absolute value, I'm sorry, square root of x minus 5. And then don't forget, there could be a positive square root and there could be a negative square root. So we always remember, think about square root of 25, right? Could be positive or negative 5. So we do the same thing here. We put in a positive and a negative. All right, so I don't know why that's not working. All right, so now let's go graph that. Give me just a minute. I'm going to graph it. You guys can try to graph it. You can put that in your calculator. If you, just for, making it easy today, go ahead and put it in both ways. You put y equals square root of x minus 5, and then you do the second one, you're going to do y equals negative square root of x minus 5. So take a minute and do that, and then see what it looks like. All right, so the one I just graphed is actually the original function, which is y equals x squared. Was it minus 5 or plus 5? I think it was plus 5, wasn't it? So I put it in the wrong spot. I need to slide that down. So y equals x squared plus 5. So let's just move this up to the plus 5. There you go. And move this one up to the plus 5. There we go. All right, so that's what that one looks like. Once you go and graph the inverse of that, you're going to see that it's going to be a parabola, but it's going to be turned on its side. So if you think about this, look at this. Now you know how to do translations. That minus means it's going to move to the right 5. So 1, 2, 3, 4, 5. You're going to go that way, kind of, sort of, right? And then the one that's a negative is going to go underneath. So it's going to go this way. All right. So again, these two graphs, or these two functions, are symmetric with respect to the line y equals x. So there's your line y equals x, and look how these look like mirror images on each other. So is the inverse a function? Well, I don't think so, because it doesn't cross, it crosses too many times. So no, it is not a function. All right, let's go and look at it one more, and then I'm going to let you work on your assignment. So here we go. We got f of x equals 10 minus 3x. We're going to find each of the following. So let's find the domain and range of f. So if you graphed it, you're going to see that this is a line. All right, there's no square root, there's no denominator. So our domain is going to be negative infinity to positive infinity. I'm going to start writing it like that. And our range is also going to be negative infinity to positive infinity, because there's nothing that it can't be. All right, now let's try to find the inverse of the function f. So go ahead and turn your f of x into a y. So this is y equals 10 minus 3x. We're going to end up going, changing our x's and our y's. So we've got x equals 10 minus 3y. And the very next thing you do is just solve for y. So I'm going to subtract 10. And I get x minus 10 is equal to negative 3y. I'm going to come over here and finish working on that. It looks like we need to divide everybody by negative 3. So we've got x minus 10 over negative 3 is equal to y. Now you can keep it like that if you like, or you can simplify each of the fractions. So you can change it to say negative x over 3, or 1/3 x, all right, plus 10/3 is equal to y, all right, or equal to f inverse of x. So we'll go ahead and put that in there. It looks like it stayed linear, of course, because there is no inverse of a linear that's going to turn into anything else. They're always going to stay linear. All right, so the domain and range, again, will be all reals. So your domain's going to be all reals. Your range is going to be all reals. And if you graph it, if you look at the table, yes, it is a function. They are both linear equations. All right, so let's go, and here's your assignment. Let me move this little box over for you. I can't do it. Hold on one second. All right, so you're going to be on page 156 and 157. I already pulled those up for you, so these are right here in this video for you. But it says choose 5. You might as well do all 9 because tomorrow you're going to do 4 more. So if you want to get ahead, you can do all 9 right now. We're going to do something else with them tomorrow. So you could do all 5, that's the minimum, but remember you're going to end up doing all 9 again tomorrow, so you might as well, you're going to do the other 4 tomorrow, so you might as well just do them now. All right, I will see you tomorrow, and I will give you back your test tomorrow, and if you haven't finished the test, that's going to happen tomorrow during RAM also. All right, have a great day.